watching a Formula One race.
It's a beautiful day, cars are whizzing by, and to pass the time, you decide to graph out where the cars are at certain points. Once the race is over, you go home and plot this information out on a graph. You're a terrific math student, so you know that the slope of this graph will tell you how fast the cars were going. Quickly though, you find you have a problem. You know how to find the slope from algebra, but when the graph looks like this, how on earth are you supposed to find the speed?
Now, I'm clearly not an artist, and I actually don't know that much about Formula One racing, but I do know how to solve this with calculus. Now, don't worry, you may think that calculus is this impossible task with weird symbols, and it's a subject everyone spends hours studying and crying over. That last part is somewhat accurate, but the concepts behind calculus are actually relatively simple, and today we're going to use one to solve this: derivatives.
The derivative is the instantaneous slope of a function. In algebra, you found the slope of a straight line, and the slope didn't change. For straight lines, it's always the same. In other functions, the slope is constantly changing and is different at every point. Taking the derivative will either give you a formula for or directly tell you what the different slopes are at these points. Now you know what a derivative is, but how do you actually find it? The easiest way is to use the function. This graph is actually the graph of x squared, and now that we have the function, we're going to use what's called the chain rule. In the chain rule, the exponent becomes the coefficient, and then you subtract 1 from the exponent, so x squared becomes 2x. Plug in any point you want, and you'll find the speed of the car at that point.
And there you go! Now, I made the function pretty basic, and calc does get harder than that, but it's way easier than it looks, and it's really just a continuation of algebra. Plus, once you understand it, you can do anything from predict world economic trends to designing new technology as an engineer. But even if you don't want to do any of that, I hope calculus may seem a little less horrifying than you thought. Thanks for watching!